presentation, this lesson, is all about immunity. It's all about immunity. And we're going to discuss the various ways in which we have, or we can get immunity, or that we've manipulated the science behind immunity to our advantage. Okay? This PowerPoint, again, is on Teams in its entirety, and you can clearly see what the starting slide is. Okay, our learning outcome is to further understand the body's specific responses against diseases and infections. Again, emphasising the fact that this is our specific defences, not our overall general defences, but specific defences against disease and infection. Is everybody excited? They should be, because it's kind of really cool. So. Now, when we talk about immunity, we will see that we divide this word immunity into two particular headings. We talk about what is called active immunity, and we talk about what is called passive immunity. Throughout this particular presentation, whenever I am talking about active immunity, everything will be in red. When I'm talking about passive immunity, everything will be in green. You will notice, even from this slide, that active immunity is divided into two, natural and artificial. And again, passive immunity is divided into two, natural and artificial. And some of you have probably already twigged, if you're thinking about it right now, that artificial immunity is basically vaccination. Artificial immunity is vaccination. So right away, even on this early slide, we can kind of think that we can have a vaccination which is passive immunity and a vaccination which is active immunity. So not all types of vaccination are the same. They work in two different ways. They're both artificial because you are doing it to somebody else. You're not catching a disease in the community. But that vaccination is either artificial, passive immunity, or the vaccination is artificial, active immunity. So not all vaccinations are the same. Let's have a look at this slide. I want to pause on this slide because it's a great slide for you to copy, a great slide for you to use or draw for the work that you're actually doing for me. Let's just get rid of that word up here, which is immunity. I just want to leave that as immunity. I just want to get that word out as immunity. You will notice, and we've just kind of already said it, that we can divide immunity generally into two big headings. Everything on this side you'll notice is red, everything on this side you'll notice is green. Immunity can either be active or passive. Now, key difference right away, just using this slide. Bits that I want to see you bring out almost immediately when you are doing this particular piece of work for me. Active immunity, antibodies produced in the person's body. In other words, in active immunity, the antibodies are produced by the person. Contrast that with over here, where the antibodies are produced from another organism, or maybe another person. So on this side, in active immunity, the person themselves is producing their own antibodies. On this side, the person receiving them is actually receiving antibodies that have been produced somewhere else. In other words, maybe in mother or maybe in another organism. Number two, you will notice down here in both natural and artificial active immunity that a pathogen enters the body. A pathogen enters the body. In natural active immunity, that pathogen enters in what we would call a natural manner. In other words, you've caught a cold standing outside Sainsbury's. It enters as a natural way. In artificial active immunity, the pathogen hasn't entered naturally. Somebody has actually given you a safe form of that pathogen. In other words, now what we're talking about is vaccination. But in each case On this side, the pathogen has actually entered the person, as a result of which the person has made antibodies, as a result of which the person has made memory cells, as a result of which the person, in theory, has lifelong immunity. The overall disadvantage of this side is that this process, if it's the first time that you have ever met this pathogen, the disadvantage is it takes time. It takes time for you to produce those memory cells. It takes time for you to produce those antibodies. It takes time, 5 or 6 days, for you to produce both of these that will eventually, in theory, give you lifelong immunity. Compare and contrast that with what's going on over here. On this side, let's just remind ourselves, now we have antibodies that have been produced somewhere else that have now entered a person's body. Okay? On this side, can you now see antibodies, not pathogens, antibodies have entered a person in a natural manner? What do we mean by that? Well, very often we can talk about antibodies that can cross the placenta or antibodies that are in colostrum, the first milk that mum has produced. Are they produced in a natural way? Yes, they are. Okay? But does the baby produce them? No. Mum has produced them and passported them to the baby. Artificially, antibodies are injected into a person. Again, this is a form of vaccination. But in this particular case, it is antibodies that are being injected into a person, like anti-tetanus injections, whereas before it was the pathogen that was being injected into a person. Okay, let's look at the advantage of this side. Number one, the advantage is again time, because in this side of the equation, this all happens really quick. In other words, once that particular person or baby has actually got those antibodies in their bloodstream, you can theoretically think they have immediate protection. Remember, on this side, they did not have immediate protection. It took time for that protection to develop. What is the downside of this, I hear you say, okay? So, the downside of this is that antibodies will degrade. Antibodies will degrade over time. So once you get immediate protection, that protection will drop off over time. The other major disadvantage is because you've only ever been given the antibodies, and this is really important, you have not got the memory of how to make them. You've just been given the finished product. You have not made your own memory cells, which means you do not get lifelong immunity. Immunity is time limited on this side of the equation because you have not produced memory cells. On this side of the equation, the disadvantage is time. It's a disadvantage, but the advantage you get is that you do produce antibodies, you do produce memory cells, you do, in theory, get lifelong immunity. Now, on the work that you produced for me, drawing this out, okay, while still referencing it because it's not your work, would be a great way of introducing this. But what I'd also like you to see, what I'd like to see you do, is kind of some of the wording that I've put around here, drawing my attention to the fact that immediately you kind of understand what the limitations and advantages are on both sides of this particular diagram. Is that okay for everybody? Brilliant. So let's move on, and now we're going to describe each of these in sequence. Okay. So, a lot of writing on here. You do not need to research or go anywhere else to get a D-grade response whilst describing active, natural immunity other than what is on this slide. Now, I am not going to read out all of this because you can all read that because this PowerPoint is on Teams. But let me just give you the highlights. Naturally acquired active immunity occurs when you encounter a pathogen in your everyday life. If you get a sore throat, if you get a cold, you are encountering a pathogen in the environment naturally. What then happens? We kind of know a little bit about this now. We know that that pathogen is then going to activate your own immune system. It's going to cross-react with one specific type of lymphocyte in your body, in a lymph node, and that particular lymphocyte is now going to divide to make thousands and thousands and thousands and millions of copies of itself. You know that some of those are going to be plasma cells. You know that those plasma cells are going to produce antibodies. Those antibodies give you your primary response. They are going to defeat the pathogen that is in your body, the cold or the sore throat. But you also know that your memory cells are also going to be produced at the end of that process. Those memory cells become the foundations of your immunological memory. In other words, you remember that pathogen like an elephant never forgets for the rest of your life in theory. So you now have lifelong immunity to that particular pathogen, which means a cold that I caught when I was 3, if my immune system is working correctly, I still have memory cells in my lymph nodes right now that will protect me for the rest of my life against that particular pathogen. So in this particular case, again, remembering, I encounter the pathogen naturally, I create memory cells, I get lifelong immunity. Okay. That is basically encapsulating what I've just said. So that's a great response to active natural immunity. Active artificial immunity is the basis behind immunization. You may know it as vaccination. Okay? It is the deliberate, what we call induction. In other words, we are tricking your immune system to respond to a pathogen that it has not met naturally. Okay? Because in this particular case, we are going to introduce a pathogen into your body that is going to stimulate your immune system to make memory cells. Because this particular type of vaccination is all about producing memory cells. In other words, this particular type of immunity is all about giving you, in theory, lifelong immunity. Okay? That's what it's about. It's not about protecting you from the here and now. Because the disadvantage of active artificial immunity, as we just discussed, is it takes your body time to do it. That's why, for example, kids have measles virus. They catch measles. If they catch measles naturally, they will produce memory cells. But you don't want to have that happen. You want to protect your children. So what you will do is, you will go to your health centre and you will be given a vaccination against measles. That vaccination against measles is not protecting you because you have measles, it's protecting you from measles you might encounter in the future. Okay? So this type of vaccination, active artificial immunity, the vaccination is specifically geared not to protect you right now because you've caught something, but to protect you because you might catch something in the future. Because the limitation of this is that it takes time for your body to produce those memory cells. But once you've produced them, from that first exposure, in theory, you will remember that for life. So I was vaccinated against measles probably when I was about 6. In theory, from 6 until 60, I have been protected by that vaccination.
because I have memory cells in me from that first exposure that was safely given to me, and they are protecting me now. I have encountered the measles virus thousands of times in the community. We all have. But we've never got ill. We've never got ill because our immune system is killing it before it can affect us, all because of those memory cells. Brilliant. Now, what I want to look at here specifically are these 3 ways in which we safely give you a vaccination that is going to produce memory cells. Just up here, just a quickie, you don't need to put this in the report, but I always put it in for students. Just so as you know, active artificial immunity is considered to be one of the highlights of the scientific development in pathogens that we have ever created. It's a massive tick in the box for us because vaccination literally saves millions of lives every year. Vaccination has statistically eradicated smallpox from this planet. It is fantastic at what it does. Now, in the case of active artificial immunity, it would be kind of paradoxical if I said to protect you from smallpox, I had to give you smallpox, because that's not going to work. So vaccinations which are active and artificial very often will either kill or they will weaken the pathogen so that it does not affect you seriously. But you can get some minor side effects from these vaccinations. So, 3 general types of vaccination we're going to look at right now, what we call live attenuated, inactivated, and subunit vaccines. These are all designed to prompt your immune system to make memory cells, which should in theory give you lifelong immunity. So, in terms of our first one, live attenuated. Attenuated just means weakened. They are weakened, but they are still alive. Now I know a virus isn't alive, so we'll just call them viable. So in theory, you are more likely to get some minor side effects from this one than any of the others we're about to discuss. But the live attenuated vaccines tend to produce the best results in stimulating your memory cells. These tend to be the ones that really will give you lifelong immunity. So, what do? We take a virus, or we take a bacteria that are whole. We put them in the laboratory, bish bash bosh, chicken dinner, it's a winner. When they come out the other end, they are weakened, they are attenuated. It does not mean that they are dead or not viable, they are just weakened. Great example, and I want you to use this when you're doing the work for me. Great example is the measles virus and oral poliovirus. Both of these are viable but weakened forms of the actual pathogen themselves. They are great at producing lifelong protection. In some cases you will find with measles, if your children have had them or if you've had them, very often they may produce a very weakened kind of symptom. So sometimes children might get a temperature or they might get a rash. However, in very rare situations, for example, the polio vaccine, something statistically like maybe 1 child in every 1 to 10 million may in fact get some form of minor paralysis as a result of oral polio vaccine. Now, this is quite an old slide now, and these vaccines have got better. But the point I'm making is here that the chances of your child getting polio are higher than 1 in 10 million. So even though there is a very minor risk of some side effects that may not go away completely, the risk of a child catching polio is significantly higher. So they are well worth having. Now, number 2, what do? These are safer, because in this particular case, what we do is we take the whole pathogen and we inactivate it. We grow the virus, we grow the bacteria, and then effectively we kill it. These cannot, repeat, cannot cause you any problems whatsoever. They cannot cause the disease state. And again, great example of an inactivated vaccine, the inactivated pathogen to give you lifelong immunity. This one is whooping cough. We take the whole thing, we basically completely kill it, and then we inject it into your body. It still produces that immune response. Your lymphocytes still detect its presence, even though it's dead. They react to what it is. They produce antibodies, but what we really want is those memory cells that are going to last you a lifetime, in theory. And finally, we have subunit vaccines. Subunit vaccines, again, really, really safe because they are not viable. In other words, in this particular case, what we do is we take the pathogen and we literally, chemically, split it into its constituent bits. This cannot cause a disease because it has been completely inactivated. But the surface-mounted receptors that it has on its surface, the antigen markers, are still sufficient to bind onto the surface-mounted receptors of a lymphocyte and produce an immune response. An immune response which is going to give us, eventually, memory cells. And again, great examples of this, I want to bring this out when you're doing the work for me, is diphtheria. And I'm going to come back to this one, and this is really important for those of you who are looking for a higher grade to concentrate on this next bit. And tetanus, because we are going to meet tetanus again in the future when we talk about another type of vaccination. So, I'm going to pause here for a second. I want you all to listen carefully. If somebody were working in an environment or starting a job where it was likely that they may come into contact with viable tetanus spores in the environment, like a gardener, like somebody working in a veterinary practice, like somebody working in a dogs or cats rescue centre, they haven't started, but there is a likelihood that during the course of their paid employment, they may come into contact with tetanus. This is the type of vaccination you would give them. Why? Because once they've had this type of injection, they have got, in theory, lifelong immunity. You give it once, you create memory cells, and you have now got lifelong immunity against tetanus. It protects that worker for the rest of their lives against tetanus whilst they're working in that particular field. Lifelong protection, sub-unit vaccine. Okay? When you read the actual assignment brief, you will see there is a question on the different types of tetanus vaccine. There is another one that's coming up. I need you to be able to compare and contrast the two. Why would we give this one now and not give it later on? So store that one away. Okay? Okay. You'll now notice that everything has changed green. So now we have moved away from active and now we are talking about passive. Passive natural immunity is one that you know all too well, especially the mums, okay? Because this is a cornerstone of pregnancy. You probably all know that when you are pregnant, sometimes you may see that the midwife will actually ask you, what has been your vaccination history? What have you been vaccinated against? And if there is deficiency in your vaccination history, then they may actually vaccinate you. They're not protecting you. What they want is that they want you, as the mother, to basically produce antibodies that are going to go into the unborn child. In other words, you passport some of your immunity into the child that you are carrying at that time. You do not, in these particular cases, passport the memory to the child of how to make the antibody, all you are doing is you are passporting the antibody to the child. And as we previously said, a limitation of this, and it is a limitation, is that once baby is born, those circulating antibodies in baby are literally realistically only going to last round about maximum 6 months, many of them, before they start to degrade. This is brilliant at what it does, because it gives a newborn baby born naked in more ways than one, because its immune system is potentially naked, because it's never encountered a pathogen before. What this allows is that the baby is born with a passported antibody profile based around what mum has encountered in her life. That's great, because if you think about it, the baby is being born protected against many of the pathogens that are in the community within which mum is actually living. It's a fantastic way of providing immediate, and that's the key on this slide, guys, immediate protection. You can't afford for baby to start making its own memory cells at this stage because it's too vulnerable. You want to protect it right now. And that's what you do here. You do it both through the placenta for those small antibodies, and you also do it through clostridium, which is the milk product that is released during the first 3 to 4 days of breastfeeding. The actual milk product basically lines all the gastrointestinal tract, because basically, and you'll see this on another slide on the PowerPoint, baby stomach acid, which normally destroys pathogens, doesn't kick in for a little while. So effectively, you haven't got that protection in the stomach of the acid destroying any pathogens that baby might swallow. So the antibodies in milk completely line the gastrointestinal tract, which means baby is protected. But whilst that protection is immediate, big tick in the box, it's time limited, because baby has not got the memory of how to make these antibodies. They've just been given to the baby. And then we do the one for clostridium as well. Now, let's go on to number 4, passive artificially acquired immunity. This again is a vaccination. But this vaccination differs from the ones we've discussed previously. Because in this particular situation, antibodies are formed in a host. Okay? That host is not you. So that host could be a horse. So the antibodies are formed somewhere else. They are then removed from the horse, the host, and they are then transferred into you. Again, advantage, it's immediate. Disadvantage, you do not get lifelong immunity because you do not create memory cells. So when might we use this particular type of vaccination? Remember I said about tetanus? Here we are again. Tetanus antitoxin is a perfect example of a vaccination that is passive, artificially acquired. Now, we all know that tetanus lives in soil. We all know that it kind of lives in dog feces and cat feces and stuff like that. And that if you get a puncture wound, most often, it is the actual, what we call endospores of the tetanus toxin that get in. Tetanus is a fucking serious condition. You do not have time on your side. If tetanus gets in, you are in serious trouble, and you're in serious trouble very quickly. The general consensus on mortality rates with tetanus is literally flipping the coin. 50% live, 50% die. It's a serious and immediate risk. So, let's go back to our scenario. Let's say, for example, we have somebody working in a dog's trust. They're outside, they've fallen over, they've cut their hand, They slapped their hand in a big dog poo and got dirt in it as well. If that happens, there is a risk of tetanus, and that risk of tetanus, the clock starts ticking now. You have not got much time. Do you think you would then use the previous type of vaccination, the one that you would actually give a safe form of tetanus, so that your body could then build up and produce a clone army, which would then lead to memory cells and basically defeat the actual tetanus toxin in round about 14 days? No, because in 14 days, technically you could be dead. So you can't afford to wait. You can't afford to naturally respond to it or even use the previous type of vaccination. You need protection and you need it now. And the only way you get immediate protection is if you chuck in a shed load of antibodies. You inject preformed, pre-made, specific antibodies that have been produced by a horse, and you inject them into that person right now. You have to inject the antibodies right now because the antibodies will immediately go to work. They will seek out and they will destroy any tetanus pathogens or endospores that have got into your body. They will get rid of them in your bloodstream. They will get rid of everything immediately. Because you haven't got time on your side. You haven't got time on your side. You need to get rid of this pathogen before it kills you. So you can't wait to produce memory cells. You want the product, antibodies, and you want them now. You need them now. Now, whilst they provide immediate protection, big tick in the box, we also know that that protection is time limited. Because this type of vaccination does not produce memory cells. So vaccinations of this type, responding to an accident, responding to the here and now, responding to the A&E admission of the hand being hurt and all dirt and poo being in it, you would give them this type of vaccination. You would not, repeat, not give them this type of vaccination, because this one takes too much time. You haven't got time on your side. By the time you had mounted a response by making plasma cells and memory cells, but particularly plasma cells, you could be dead, which is why you need that one. And you need to bring that out, and you need to explain that when you're actually doing your report form. So any questions at all? Ask me in the sessions. Don't forget the PowerPoint is on Teams. Hope you kind of enjoyed that whistle-stop tour through immunity.